So the question says, fundraising. The table shows the amount of money in a booster club. So booster clubs are a club that raises money for the school to boost what we can offer. Made washing cars for a fundraiser. Use the information to find the rate of change in dollars per car. Now they're telling you exactly what your label on your answer is going to be, dollars per car. Okay? It has to be dollars per car. We can use the dollar sign, but it's dollars per car. All right, so we're looking at this. Here's the number of cars washed, and here's the money that they're raising. Now, we don't need this many points. We only need a couple. So let's just choose these first two. So which is my dependent variable? The cars or the money raised? What's dependent?
The thing that
The one that doesn't rely on.
Yeah.
No, dependent's the one that does rely.
Yeah.
So the one that does rely is money. So money is going to be dependent because it depends on how many cars you wash. So we're going to do the change in money on the top and the change in the number of cars on the bottom. And that makes sense because it says dollars per car, so dollars needs to be first anyway. So I'm going to look at my change in dollars. So I'm going to actually write out the math. 80 minus 40 is our dollars. I'll just put a dollar sign there to help me remember that that's dollars. And then the number of cars, 10 minus 5, that's going to be cars. So 80 minus 40 is 40. So $40. And then 10 minus 5 is 5 cars. So it's $40 for every 5 cars. But we want to reduce that down to what we call a unit rate. So 40 and 5 both divide by 5. What's 40 divided by 5?
Is it 8?
8, good. So it's $8 then for 1 car if I take this and reduce it. Reduce. And so then that's $8 per car. Do not put the dollar sign after the number because that's wrong. I don't know why that's become a thing. A lot of students will write the 8 and then I think it's because we say $8, but the dollar sign goes in front of the dollars. So it's $8 per car.
On that thing, it doesn't say find the unit rate. Do you still have to?
If it does down here, it says find the unit rate.
Oh, well, I don't
So use the information to find the rate of change. So the rate of change and the unit rate basically, so it says find the unit rate to determine the rate of change. So that was like the rest of the directions. I don't know if I read that part. But it's all the same thing. So the rate of change and the unit rate are basically the same thing. Except we could have written the rate of change as $40 for 5 cars. What they're telling us with the unit rate is to reduce it all the way down. They want to know what it is for 1 car, which is useful. Like if you had this table and like this is how things had gone throughout the day and you're like, wait, how much are we charging per car? You could figure it out.
Wait, why do you I'm trying to think how I'm going to phrase this question.
Okay.
Okay.
It's okay.
Why did you only use those 2 numbers? Can you do that?
Because if this is a straight line, which is what we have to assume if they tell us to do rate of change or unit rate, I only need a y2 minus y1, x2 minus x1. I don't need the other numbers.
The bottom 2, I could do the bottom 2.
You could do the bottom 2, same answer.
Okay.
Because 60 minus 120 is still 40. 20 minus 15 is still 5. And sometimes they don't come out to the same numbers, but they'll reduce to the same number. Okay? Yeah, you can pick any whatever numbers you want as long as you're choosing 2 complete sets.
Okay.
Okay, so let's go down to the bottom. Driving, some of you will be doing this soon. It's a little scary. The graph represents the distance traveled while driving on a highway. Use the graph to find the rate of change in miles per hour. Gee, miles per hour sounds a lot like velocity.
No. How about no?
So if you guys have done velocity graphs before, it is exactly rate of change. It is slope. It all ties into what we do in math as well. So they've actually given us 3 different points on here just to point out when you are doing these from a graph, you want to have exact points that you know exactly what those numbers are as much as possible. So what they did, if you look at this line, this isn't crossing in a really clear place, but this one is. That one's not crossing in a clear place, but that one is. And so we can kind of see where this is at. So it says use the graph to find the rate of change. So what we'll do here is just look at the rise and the run. So we can still do rise over run. Now we do have to pay attention to the scale because they're not going by ones in either direction. What are these boxes going by for distance in miles? 20s. So if I use, you see this little dashed line they've drawn for us? This would be 20, 40, 60. So that's 60 miles. And that's my rise is 60 miles. And I'm going to keep the label. And then I'm running, it looks like 2 hours, but if I come down here to look, each box is only half an hour. So if they went from 1 to 2, it's just 1 hour. So lucky for us, it's already a unit rate. So we can just say 60 miles per hour. Or MPH is how they do miles per hour. Now, if it wasn't that easy, let's say that they did the first point and the third point, and they went from here all the way up there. Well, then I'd get 120, and I would get 2. And so 120 divided by 2 is still going to be 60. It doesn't matter what 2 points you pick if it's a straight line. But we wouldn't be doing this if it weren't a straight line. So if it's a straight line, that rise over run will be the same all the way up. Okay, so let's do the second page. So driving, use the graph to find the rate of change in miles per hour. Look, they're giving us the label again, while driving in the city. So similar graph, we have some things pointed out here. Now let's pretend that they didn't put these little lines on here for you. Let's pretend that they weren't showing us the rise and the run. If they weren't showing you the rise and the run, you could pick a couple points and do the slope formula, y2 minus y1. So let's do this one that way. And then we'll look at the graph. Because sometimes they'll tell you what the points are, but they won't actually show you on the graph. And this one kind of starts in the middle, so we want to make sure that we're getting exact numbers. So if I'm using the first 2 points, my y2 would be 60, and my y1 would be 30. Because that would be my change in y, this distance right here. So that means this distance right here must be 30. And then if I'm doing my x2 minus x1, I'm going from my y2 is 2, my y1 is 1, so 2 minus 1. So I'm going, that's miles, and this is hours. So I'm going to have 30 miles in 1 hour, so 30 miles per hour. And so if we look, this is 30, and this is 1, so it works. But this has kind of a weird scale. Those little 0.5s throw people off a lot. They're going by 20s. So this is another route. You can do it on the graph, but if you know exact points, doing this quick formula can get you for sure the right answer. So they can give you points, they can give you a graph, they can give you a table. Theoretically, we can do this with anything. All right, so let's look at this, physical science. I know you're excited to see the word science, but a lot of this is science. The table below shows the relationship between the number of seconds, y, it takes to hear the thunder after a lightning strike, and the distance x you are from the lightning. So they're giving us the distance in seconds. Notice they labeled for us x and y. I don't have to think about it. Sometimes I do. But this one's different. Normally time would be our independent variable. They're saying it's not. And that's because how far away that lightning strike is what determines how long it's going to take for you to hear it. So how many seconds depends on how far away it is. Does that make sense? So this is the dependent variable this time, which is a little confusing. But because it was confusing, this book that I took it out of actually labeled it. So it says we're going to graph the data, find the slope of the line, and explain what the slope means. So they're kind of trying to trick us, but slope and rate of change are basically the same thing. Rate of change, like I defined, is just slope for real world stuff, and it has labels. So if they've already got the numbers on here for us. So distance, we go down here, so we need to make our labels. Distance, and this is in, I think it's supposed to be miles. I'm not real sure on that. It doesn't say what the distance is measured in. And then the seconds, I guess I should put time and then seconds. Hang on. It's important when we're labeling both of these that we're putting in what our labels are. If for some reason it's left out like that, let me know and I'll try to figure it out. There we go. So it's distance. We're going to say it's miles. 1 mile, 5 seconds. I don't know if that's actually it, but we'll pretend it is. All right, so my first point is 0, 0. So that's right here. And then my next point is 1, 5. So it's 1 mile we're saying. So I'm going to go over 1 mile and then up 5 seconds. Now notice it's going by 2. So 2, 4, 5 is between 4 and 6. I know that's shocking.
Whoa.
And then we have 2 tens. So 2 miles, 10 seconds. So 2, 10. 3, 15. 15 is between 14 and 16. 4, 20. And 5, 25. So this is an actual relationship that should make a straight line. This is not a scatter plot. And because of that, we're just going to connect the points. If you don't have something straight to use, you could try to freehand it. Just make sure all of your points are labeled. I prefer rulers. That's okay. They grabbed rulers. It's good. I've got more up here if you want one. No. Sam, do you want one? You got it? Okay. So this keeps going. Now I put an arrow on this end of my line, but I left this end as a point. So it's actually a ray, not a line. Why wouldn't I make this a full line and put the arrow go this way?
Because it starts at the...
Because it can go on for infinity into the negatives and all that.
Okay, so it goes forever not to the negatives. It goes forever into positive numbers because we're talking about miles and seconds. We can't really do negative miles and seconds. So that's why it starts at 0, 0. I think you were on the right track. Maybe it just didn't come out. So we're going to find the slope of this. So we have some options. You can kind of look at the graph, but we have points. Anytime they give you 0, 0, I want to encourage you to use the 0, 0 because it makes the math really, really easy. So if I'm doing y2 minus y1 over x2 minus x1, here's my y's. I'm going to do 5 minus 0. And then I'm going to do 1 minus 0. Which gives me, and I should label this, so this is seconds, and this is miles.
I worked ahead and I did 1 and 2, but...
You did this one? It'll still work out. So you should end up with 5 seconds over 1 mile and get 5 seconds per mile.
Yeah.
Yep, okay. Yeah, you can use any 2 points that you want. Because if I subtract 10 and 5, I'll still get 5, and 2 and 1 still gives me 2. I could use 25 and 5, which would give me 20. And 5 and 1, which is 4, and then 20 divided by 4 is still 5. Because this is a straight line, any 2 points that you use will give you the same slope. Okay,
Hey, I
that's
actually
it.
understand now something in math class.